So in case no one's told you already, nobody really understands how AI works. We grew it like a plant. The farmer doesn't know how plants work most of the time. All he knows is that when he puts a seed in the ground and the seed gets water and sunlight, a plant grows. That's sort of how AI engineers do things. All they know is that when they give enough data and enough compute power and enough memory on a computer, and they give a computer program a reward for solving a problem a certain way, they can end up with an intelligence. They have no idea the inner workings of such intelligence. Every single AI model with which you have interacted in your life is essentially, at its bare bones, a group of numbers. That is what an AI model really is. This is called the black box problem. When you look at an AI, all you see in the brain is trillions of numbers. It used to be hundreds of billions, now it's working on trillions. This is the main reason why AI is considered so dangerous by the experts who talk about it. We don't understand it. So if it gets so powerful to the point where it's more intelligent than us, and we don't even know what it wants, what its goals are, we don't know its intentions, who knows what can happen? It's possible something bad won't happen. It's possible something great will happen. It's possible something medium will happen. The problem is that we don't know. Nobody knows. A common question I get asked is, why don't you just delete the code that is instructing the robot to kill all humans, if that even exists? That's not a thing. We don't have a single line of code for every single behavior of an artificial intelligence. All we have are trillions of numbers that we don't understand. And here's the kicker. Any one of these numbers can represent more than one thing. They can represent 10 to 100 or so things, because even with a trillion numbers, that's not enough to fit the capacity of a super intelligence. It needs to be efficient with the amount of numbers it has. Which does make sense when you take into account the fact that the human brain has like 10 trillion synapses or so. If we don't have an understanding of them before they really pull ahead, we're kind of flying blind. But on the flip side, if we do get an understanding of these models, we can harness their power. We can use them for the good of humanity if they fall into the right hands. Which is another conversation entirely, though I am more optimistic than most about that. But what do you do to get an understanding of these trillions of numbers? This sounds incredibly complicated. Where do you begin? Well, what you do is you train another AI. And that might sound a little counterproductive, because what if the second AI gets so smart that you end up with the same problem of understanding it? And the reason we're not as scared about that is that it's a narrow AI. Consider something like a chess AI or a self-driving car. It doesn't have general intelligence, meaning it doesn't have a full scope of reality. It only has intelligence for a narrow domain. So it's less threatening to us because it just can't synthesize goals or strategy the same way that a human can. Though it is not out of the cards that it could develop general intelligence, as an instrumental need for its narrow goal, which is something we would need to look out for. But as long as it stays narrow, it's mostly pretty safe. We don't have to worry about it nearly as much as general intelligence. So you take this model, and what you do is you train it on activation patterns of a regular base AI model, a frontier model like ChatGPT or Gemini or Claude or whatever. What I mean by activation is basically when you type a prompt into a chatbot like ChatGPT. If you have an AI model running on your computer, then you have access to the weights, and you can observe when you type in a prompt like, what color is an apple? You can observe which neurons, which numbers in the network fire, and when, and in what direction. And you can observe what type of activations, what kind of electrical firings happen when you type in a prompt like, what color is an apple? And then what kind of firings take place when you type in a prompt like, what's the capital of France? You can observe the differences between the activations and start to pick out what parts of the AI represent which concepts. And I'm just now starting to learn about this, by the way. I am in no way an expert. If it sounds like I'm stumbling over my words a little bit, it's because I don't quite understand this completely myself. I'm just relaying what I'm learning. And obviously, as I said, it's not you doing this. It's not a human doing this. That would take hundreds of thousands of years. This is an AI being trained on millions, billions of activations and all kinds of different prompts to try to get a full, God, I just spit like a motherfucker. Just try to get a full picture of what's going on in the mind of the network. This tool that I'm describing is called a sparse autoencoder. The word sparse here means that instead of having an AI model where every single neuron represents 10 to 100 different concepts, try to have each segment of the sparse autoencoder's output, try to have each segment represent one feature, one concept, so that we can actually understand it and read it. And autoencoder is pretty self-explanatory, but you're basically taking the activation pattern from the AI model, running it through, and it is encoding it to make it understandable by a human. Now, does it turn it into like readable human language? I don't think so. I think it turns it into just some kind of, I don't know, cryptographic code that we can understand, that isn't necessarily language, but it's like something we can read. I don't know exactly. It's confusing, but once you're done, you can get to a point where you have certain understandings of what features the model has and how to clamp those features so that they don't exist. You can sort of start to perform brain surgery on the model. And a toy experiment that Anthropic did, Anthropic owns Claude. They train the model Claude, which is a competitor to ChatGPT and Gemini. They did a toy experiment where they figured out Claude's concept of the Golden Gate Bridge. They figured out where in Claude's mind it understood the idea of the Golden Gate Bridge. And then they released this model called, I don't know, Claude Golden Gate Bridge or something dumb, I don't know. But they clamped down on the Golden Gate Bridge feature, and then the model only wanted to talk about the Golden Gate Bridge. No matter what question you asked it. You could say, how's it going today, Claude? It would say, it's going great. I'm feeling amazing, like someone who's walking on the Golden Gate Bridge right now. Or you could ask it, what are the results from the last WrestleMania? I think I don't know much about wrestling, but it would say like, oh, it's nothing compared to what's going on with the Golden Gate Bridge right now. It got very specific. It developed this fetish for the Golden Gate Bridge, essentially.